Imagine we have two pods and two services with their IP addresses. And we tell my app pod to talk to my DB service using the service name. Applications can only send a request to an IP address. So how do we tell the pod my app what the IP address of the service named my DB is? The simplest way would be to write it in its /etc/hosts file. As you learned in the DNS prerequisites video, this is the first place to look for a domain name to IP address mapping. The same way when my DB pod wants to talk to my app service, we can tell it which IP address my app service has by adding the mapping in my DB pod's /etc/hosts file. Now, of course, if we have hundreds of services and all the pods are talking to all the services, this will be a lot of DNS mappings to manage per pod. So instead, it makes much more sense to have all these mappings of service domain names to their IP addresses in a centralized place, instead of each pod having its own huge list of them. And that centralized place is the DNS server. So now instead of listing all the mappings in each pod in the /etc/hosts file, you can simply point the pods to the name server which has all the records. You can do that by specifying the address of the domain name server in the /etc/resolve.conf file in each pod. So we have a name server in the cluster that keeps track of and manages the list of all the service names and their IP addresses in the cluster. And all the pods point to it to resolve service names whenever they want to make requests to them. And the DNS server in Kubernetes cluster is core DNS. Remember when we installed the cluster with kubeadm init command, we saw that two add-ons were deployed in the cluster in addition to the master and worker processes. There was one of the last phases of the kubeadm init command execution. And one of these add-ons was core DNS application. And note that the DNS server used in Kubernetes before version 1.12 was actually kubeDNS. Starting from Kubernetes version 1.12, it was replaced by core DNS as a recommended DNS server. And as you probably also remember, core DNS is running inside the kube system namespace, and we have two replicas of it. And that is necessary for redundancy because, as you just learned, it is an important service, and if core DNS application crashed and it was not available, pods will not be able to resolve service names, and the whole communication in the cluster between the applications will be broken. So in a production cluster, you should have minimum of 2 core DNS pod replicas, preferably even more. And this also means that when developers come to you saying that service name doesn't resolve, you could first check that the core DNS pods are running and accessible. And as one way of debugging, you can also check the logs of the core DNS pods. In fact, let's actually go ahead and check the logs of core DNS pods. And we actually want to log both pods at once. So for that, let's use the labels as we learned, right? So both core DNS pods have a shared label, this one right here. So we're going to do kubectl logs in a kube system namespace and label of core DNS. It doesn't say much right here, but you could check the logs in case of some issues to troubleshoot the DNS resolution in your cluster. So the way it works is that whenever we create a service in the cluster, core DNS creates a record for that service. The record maps the name of the service to its IP address. So using this record, any pod within the cluster can now reach the service using its name, which we already saw in the Nginx pod, where we curled the Nginx service from a test pod. So now as a final step, let's also check the /etc/resolve.conf file in the pod. We still have the test pod running in the cluster, and same way as before, let's actually enter the pod environment using kubectl exec command. And inside that, we have the virtual file system of the pod. So let's check /etc/resolve conf, which is a file, so we can print the contents. And as you see right here, it says name server, pointing to our core DNS's IP address. Now let's clarify two things right here. First of all, how is this entry configured here? So who tells pod basically that the name server in the cluster is core DNS? The first one is that this IP address is not a pod IP address of core DNS. This is actually an IP address of core DNS's service. So if I exit the pod and let's check kubectl get service in kubesystem namespace, and let's filter it on DNS using grep. And this is a core DNS service, which is actually called kubedns and not core DNS. That's the name of the service. And this is the IP address that is specified right here. So we have one mapping that tells the pod, if you want to resolve any domain name, then go and talk to the name server at this IP address, which is core DNS, as we learned. So that's the first thing. The second one is, how is this actually configured? So who tells pod that this is the name server that they should use to resolve domain names? That's actually Kubelet's job. So whenever Kubelet schedules a pod, it automatically generates this file inside with these contents. And we can also check that in Kubelet's configuration, which is located in /var/lib kubelet and config.yaml file. And we need sudo permission here. And right here you see cluster DNS and the IP address of the kube DNS. The same IP address as configured here. So Kubelet actually has this information and inserts that into every pod, and that is configured right here. So that's how resolving service names to their IP addresses is configured in Kubernetes. Now what happens if I create a test pod in a different namespace than the Nginx application and its service? Can I still access the service by using its name? Well, let's try. Right now we have our test service running in the same namespace, which is the default namespace as the Nginx deployment pods, as well as Nginx service. So what we're going to do is we're going to create the same test pod in a different namespace, and then we'll try to access Nginx service from there. Right now, let's get all the namespaces that we have right here, and I'm simply going to create a new one using kubectl create namespace, and let's just call it test namespace. And then I'm going to create a pod called test nginx service. So the pod with the same name, but in a different namespace. So namespace will be test ns and not a default. And of course we need the image, which is nginx. Now remember, we were not allowed to create a pod with the same name in the same namespace, but we can create a pod with the same name in a different namespace. So let's run this and let's check that our pod is running. And now let's actually enter this pod right here and try to access the service. Again, remember kubectl exec command that lets us get an interactive terminal of any pod. And when we're working with a non-default namespace, remember we always have to specify the namespace option here with every command. So this will let us enter the test nginx service running in the test namespace. And let's connect to the service. First, I'm gonna use the IP address of the service and port 8080 to connect, and let's see. We get a reply back, right? So IP address and port, not a problem. Now let's use the service name instead, Nginx service, which is the name of the service and the port. And as you see, after a couple of seconds, we got a response here that says could not resolve host. So it's not able to find a service with this specific name. So why is that? What's happening here? For each namespace, a DNS server, which is core DNS in Kubernetes, as we've learned. So core DNS creates a subdomain. So all the pods and services are grouped together in the subdomain of the namespace. So the services in default namespace actually have an address of nginx service.default. In addition to that, all the services of all the namespaces are grouped together in another subdomain called service or SVC. So each service can actually be addressed with service name dot namespace name dot svc. And finally, Kubernetes DNS created a root domain for the cluster, which is cluster.local. So the full name of any service in the cluster would be service name dot the namespace name in which the service was created dot svc dot cluster dot local. And that's also called a fully qualified domain name of any service, or FQDN. But conveniently, as you saw, we don't have to specify the fully qualified domain name for services when we connect to them. That's why we were able to connect to the service from this pod right here, just using the name of the service. However, if the service is in a different namespace, we can't just address it with only a name. We actually need the service name and namespace name. So the way it works is that when a pod tries to connect to a service using the name of the service, Kubernetes will actually try to resolve this, and it will try to find Nginx service in the same namespace as the pod that is trying to send a request to it. So in the test.ns namespace, there is no Nginx service, and that's why we get could not resolve host. So if we want to access services from another namespace, we have to explicitly tell the domain server the subdomain of namespace name as well. So instead of Nginx service, we're going to do Nginx service.default. And let's try again. And there you go. So again, whenever we're talking to services in the same namespace, we can use just the name of the service. Whenever we want to talk to services from other namespaces, we have to specify the name of that namespace as well. And that's going to be the domain name of the service. So this is still a short form of a fully qualified domain name of the service, which would be nginx service.default.svc.cluster.local. So if we execute this, this should work as well. And as you see, it does. Now, why is that we don't have to specify the whole name and we can actually just use a shortcut, which is either service name and namespace name or just the service name? So how does that resolve to the service's fully qualified name? Well, that's because of an entry in the resolve conf file right here, which says search and then a list of subdomains in which a domain name will be searched, basically. So this means whenever a pod sends a request to a service name, the domain name server will try to resolve the service name in one of those domains. And that's the reason why we don't have to specify the whole path, because that will be automatically appended, so to say, whenever you do a search. So if the Nginx service was in the same namespace as the pod, we would not have to specify the namespace, because the core DNS will then search for this service in test NS domain. So in this domain right here, it will find one and it will give us a result. And that's why when the service is not in the same namespace, it's not going to be found here, and we need to specify a namespace name so it can be found in the next domain. So that's basically how it works. So if I enter the test Nginx service in the default namespace and print the resolve contents, you see instead of test namespace, here one of the domains in the search is default namespace. So as a troubleshooting tip, if you have an issue where accessing a service using just the name and the namespace does not work, but specifying a fully qualified name does work, it means your cluster has an issue resolving the service names, and you would know where to debug that.